Welcome to our Cosmic Comparison series. I'm excited to take you on a journey through the universe, exploring the wonders of space and comparing celestial objects. Today we're diving into the fascinating differences between the terrain and weather of Earth and Mars. These two planets, neighbors in the vast expanse of our solar system, offer a captivating study in contrasts. While Earth teems with life as we know it, Mars presents a colder, drier, and seemingly desolate landscape. But don't be fooled by appearances, my friends, for even in its starkness, Mars holds secrets and wonders that continue to beckon our curiosity. Let's begin our exploration by examining the dramatic landscapes of these two worlds. Earth, as you know, is a planet sculpted by diverse forces. We have towering mountain ranges like the Himalayas, formed over millions of years by the slow, relentless collision of tectonic plates. These geological giants pierce the sky, their snow-capped peaks a testament to the power of our planet's internal heat. Then we have the deep, echoing canyons carved by rivers over eons. The Grand Canyon, for example, stands as a breathtaking testament to the erosive power of water, a force that has shaped much of Earth's surface. And of course, we can't forget the vast oceans that dominate our planet, teeming with life and influencing our weather patterns in profound ways. Now, let's shift our gaze to Mars, a planet often called the Red Planet due to the iron oxide or rust that covers its surface. Mars may be smaller than Earth, but don't let that fool you into thinking it's short on impressive features. In fact, it boasts the largest volcano in our solar system, Olympus Mons. This behemoth dwarfs Mount Everest, rising 3 times higher and spanning an area roughly the size of the state of Arizona. Imagine the eruption that created this monstrous mountain, and if you think the Grand Canyon is impressive, Mars has a canyon system that would put it to shame. Valles Marineris, a system of canyons stretching across the Martian equator, is so vast it makes the Grand Canyon look like a minor crack in the sidewalk. This colossal scar on the Martian surface is thought to have formed early in Mars's history, perhaps by tectonic activity or ancient water flows. And speaking of water, evidence suggests that Mars was once a much wetter planet than it is today. We see signs of this in the dry riverbeds and ancient lake beds that crisscross its surface, hinting at a time when water may have flowed freely across the Martian landscape. Now, let's turn our attention to the dynamic atmospheres of these two planets. Earth's atmosphere is a constantly changing tapestry of weather patterns, driven by the sun's energy and the planet's rotation. We experience everything from gentle breezes to raging storms, from the life-giving rain that nourishes our forests to the delicate dance of snowflakes falling from the sky. Our planet's diverse climate zones, from the tropics to the poles, result from the uneven heating of Earth's surface by the sun. This uneven heating creates temperature differences that drive atmospheric circulation, leading to the formation of winds, clouds, and precipitation. Mars, on the other hand, has a much thinner atmosphere than Earth, about 100 times thinner, in fact. This thin atmosphere means that Mars doesn't retain heat very well, leading to frigid temperatures and dramatic temperature swings between day and night. While Mars lacks the liquid water and robust atmospheric circulation needed to produce Earth-like weather patterns, it does have its own unique atmospheric phenomena. Dust storms, for example, are a common occurrence on Mars. These storms can range in size from small dust devils to planet-encompassing events that can last for months, shrouding the entire planet in a reddish haze. And while liquid water is scarce on Mars today, its thin atmosphere does allow for the formation of clouds, though these are typically thin and wispy compared to the towering cumulonimbus clouds we see on Earth. Temperature extremes, from sweltering heat to frigid depths. When it comes to temperature, Earth and Mars are worlds apart. Earth, thanks to its relatively thick atmosphere and the greenhouse effect, enjoys a relatively stable temperature range that allows for liquid water to exist on its surface, a crucial ingredient for life as we know it. Our planet's temperatures vary depending on latitude and altitude, with the hottest temperatures typically found near the equator and the coldest at the poles. The hottest temperature ever recorded on Earth was a scorching 134 degrees Fahrenheit or 56.7 degrees Celsius in Death Valley, California, while the coldest was a bone-chilling -128.6 degrees Fahrenheit, or -89.2 degrees Celsius in Antarctica. Mars, on the other hand, is a much colder planet, with an average surface temperature of about -80 degrees Fahrenheit or -62 degrees Celsius. This frigid environment is a result of its thin atmosphere, which doesn't trap heat as effectively as Earth's atmosphere. Temperatures on Mars can fluctuate dramatically between day and night. At the equator, temperatures can reach a balmy 70 degrees Fahrenheit or 21 degrees Celsius during the day, but plummet to -100 degrees Fahrenheit or -73 degrees Celsius at night. And at the poles, temperatures can drop to a staggering -220 degrees Fahrenheit or -140 degrees Celsius, cold enough to freeze carbon dioxide out of the atmosphere and onto the surface as dry ice. Atmospheric composition, a tale of two atmospheres. The atmospheres of Earth and Mars are as different as their surfaces. Earth's atmosphere is a life-giving mixture of gases, primarily nitrogen about 78% and oxygen about 21%, with trace amounts of other gases like argon, carbon dioxide and water vapor. This delicate balance of gases is essential for life on Earth. Nitrogen provides an inert atmosphere that dilutes the oxygen, preventing it from becoming too reactive. Oxygen, of course, is essential for respiration, the process by which organisms convert food into energy, and carbon dioxide, though a trace gas, plays a crucial role in regulating Earth's temperature through the greenhouse effect. Mars's atmosphere, on the other hand, is a thin carbon dioxide-rich veil. Carbon dioxide makes up about 95% of the Martian atmosphere, with nitrogen about 2.7%, argon about 1.6%, and trace amounts of other gases making up the rest. This carbon dioxide-rich atmosphere is thought to be a remnant of a thicker atmosphere that Mars may have possessed early in its history. Over time, Mars lost much of its atmosphere to space due to its weaker gravity and the solar wind, a stream of charged particles constantly flowing from the Sun. While Mars's thin atmosphere is not conducive to life as we know it, it does offer some protection from harmful radiation from the Sun, and the presence of carbon dioxide, a greenhouse gas, means that Mars could potentially be warmed up if we could find a way to thicken its atmosphere. Seasonal changes, a tale of two tilts. Both Earth and Mars experience seasons, but the way these seasons manifest themselves is quite different on the two planets. Earth's seasons are caused by the tilt of its axis of rotation, which is tilted at an angle of about 23.5 degrees. This tilt means that different parts of Earth receive varying amounts of sunlight throughout the year. During summer in the Northern Hemisphere, for example, the Northern Hemisphere is tilted towards the Sun, receiving more direct sunlight and experiencing warmer temperatures. At the same time, the Southern Hemisphere is tilted away from the Sun, receiving less direct sunlight and experiencing winter. Mars also has a tilted axis of rotation, but its tilt is more pronounced than Earth's, at about 25 degrees. This greater tilt means that Mars experiences more extreme seasonal changes than Earth. During Martian summer in the Southern Hemisphere, for example, the southern polar cap, which is composed primarily of carbon dioxide ice, shrinks dramatically as the carbon dioxide sublimates or changes directly from a solid to a gas. This sublimation process releases large amounts of carbon dioxide into the atmosphere, increasing atmospheric pressure and driving global wind patterns. Mars's elliptical orbit also contributes to its seasonal variation. Because Mars's orbit is more elliptical than Earth's, its distance from the Sun varies more throughout the year. This variation in distance, combined with its tilted axis, leads to more extreme temperature differences between the seasons on Mars compared to Earth. So, thanks for joining us on this interplanetary journey. We've explored the dramatic landscapes, dynamic atmospheres, and extreme temperatures of Earth and Mars, two planets that share a sun but tell very different stories. From the towering peaks of Olympus Mons to the dry riverbeds of Mars, from the life-giving rain on Earth to the planet-encompassing dust storms of Mars, we've seen how these two worlds, Though neighbors in the vast expanse of space offer a captivating study in contrasts. Don't forget to like, subscribe, and hit the bell icon for more cosmic comparisons. We've only just begun our exploration of the universe, and there are many more wonders out there waiting to be discovered. See you next time.